Welcome to day 12 of the 100-day FPGA series. In today's video, we are going to be learning priority encoder. In the last video, we had done a project which was ALU, which is basically combinational logic. So this also is combinational logic, and the next video, which is the decoder, will be also combinational logic. And these two are the last videos in the series of combinational logic, right? So I think after watching these many videos, you must be able to write any combinational logic by now. So I will be I've covered essential combinational logics, and whenever you will require them in the next coming major projects, you will be able to recall them, right? So this is the second last video, and tomorrow, which is a decoder, I will show you encoder decoder loopback as well in the same video. Okay, so then we will basically have first milestone, which will be covering the combinational logic. We will cover the entire combinational logic by the next day. Okay, so today let's focus on the priority encoder. So the priority encoder is one of the combinational logics, and it works something like this. I'll explain it to you. So an encoder looks something like this. So we have I've drawn 4x2 priority encoder, and 4x2 priority encoder is one of the most basic priority encoders. So we'll start learning from here. So here what we are doing is basically taking 4 inputs, okay, and giving 2 outputs. So some people may confuse it with multiplexer. So multiplexer always has one output, demultiplexer always has one input, so there is nothing to be confused about. Multiplexer basically passes the values, whatever the input is, to the corresponding output values depending on the selection lines, right? So this is not multiplexer. The behavior here is basically these lines will change according to whichever the input you want is active. Okay, so here if I draw the truth table of this thing, so this is the truth table of the priority encoder, and here you can see depending on which input is active, whichever input is high, we are basically encoding the value. So if the 0th input is high, we are basically outputting 0 0, right? So if the I1th input is high, we are outputting 0 1, and corresponding similarly the next ones, right? But here the thing is, let's say you also may have a combination which is basically something like this, right? You can also have this combination. That is why we have priority encoder, right? So this basically prioritizes the MSB. Okay, so if the MSB bit is 1, so it will take this value only, doesn't matter whatever the value is. So this becomes don't care values. So if you read about priority encoders in the digital electronics, you will be able to understand fully whatever I'm saying. But here even if you haven't revised, I will basically tell you, see, this basically priority encoder means whatever the MSB bit is, this is prioritized. Okay, so here if this bit is 1, it doesn't matter whatever these bits are. Even if these bits are 1, it will be mapped, the outputs will be mapped according to the MSB bit. Okay, so these 2 bits basically doesn't matter if this bit is high. Okay, similarly here, these all 3 bits doesn't matter if this one is high. So this is how an encoder works. This is the theory. So depending on whatever the input value, whatever the input value is high, it will tell you, basically the outputs will tell you which value is high. Okay, also some people basically use this as binary decimal to binary converters. So in that what they think is, the mindset of thinking is basically if I have to convert the value 0 to binary, okay, if you have 0 and if you have to turn it into binary and get the corresponding binary value, so turn the I0th value as high and you will get the corresponding binary value, right, which is 0 0. If let's say you want to convert 2 as into binary, so you have you will make I2 as high. Okay, when you make I2 as high, you will get 1 0, which is the corresponding binary value of 2. So some people also this basically can also act as a integer to binary convert, decimal to binary converter as well. Okay, so this is how it is. We will just code it into Vivado and let's see, and let's implement it on the FPGA. Okay, so I have opened the Notepad ++ app here, and here we are going to code it, code our priority encoder. So begin with module. Let's just save this first. We will name it encoder like this and choose the Verilog file and then save it. Okay, so next off, so here also we have two methods of doing it. Doing the encoder, we can basically find the truth table. We can take this and solve the k map, and we'll get some expressions, and I'll write those expressions for you. When you solve the k map, you are going to get these two expressions. Okay, so we can do that, but again, after being so long in the series, you must have understood that the main power of Verilog, the main power of the main advantage of using an hardware description language is basically to do behavioral synthesis. Okay, behavioral designs. Okay, so what is behavioral design? We describe the behavior and we get the corresponding circuit. That is the plan. So this data flow and all you can do, and this is just like connecting wires. Okay, when you have gates and everything and you just define what the inputs will be connected to, that is basically wiring. Okay, the wiring thing is not that it's not that revolutionary, right? If you think about it, if you have 10 components in a circuit and you have to write the connection between all of them, then it's like manual wiring, right? If you have let's say nowadays you have billions of transistors inside a CPU, right? So you can't assign everything by your hand, right? It's like manually wiring and it is not possible, right? So what they use, everyone uses behavioral model, right? You describe the behavior of a circuit and it basically, synthesis tool basically takes the behavior and generates the output, right? This is the power of Verilog and hardware description languages, and we are going to be using that now. So you can write this as well, but let's use behavioral synthesis. Okay, behavioral modeling. So here if you go, how do we do behavioral designs? You write always block, right? I'm going to do always @ so this is combination logic. So combination logic basically depends on all the inputs. It's sensitive to all the inputs. So in the sensitivity list, which is this bracket over here, we have *. Okay, so you do begin and end, and here we will start writing the behavior. Okay, so you can have a reset here. In the last video we had seen that if you don't have a reset condition, you might have undefined values in the beginning, but here let's just see. We'll start with if else, right? So behavioral modeling, in behavioral modeling we generally use if else and those kinds of things to describe the behavior of the hardware. So here we are going to select if the input I, and this is a priority encoder, so we'll check the most the bit with most priority, which is I3 first. Okay, so I'm going to check if I3 is equal to 1. I'm gonna do y equal to, and the corresponding value is 1 1, right? So I'm gonna write 2-tick binary 1 1, and I'm gonna write else. Similarly write for other things. So if else, if I'm gonna write the second condition, which is if I2 is equal to 1. Alright, so this is the condition, the if else chain that we have written. Since we are in notepad here, we'll just write a test bench as well. Okay, so I'll write a test bench. So module, first step is instantiation of the DUT, so I'm going to instantiate this thing. Okay, so I've written the test bench here as well, and as you can see, I have given 4 conditions according to the truth table here, and there are 2 additional conditions which I have given, in which I have turned more than one of the inputs as high. Okay, so as to test the priority encoder thing. So let's put this on the Vivado and check whether it's performing nicely or not. So I will open the Vivado. We are directly going to add the files. I have added the design source over here, and you can see this is the design source, and the simulation source is the test bench is included here. Okay, so let's run the simulation. So these are the answers over here. So the radix I have changed. What I'm going to do is I'm going to change the radix to binary. Okay, so this is how you can change the base over here, and here you can see when the first I0 input is 1, we are getting 0 0, and I1 is 1, we are getting 0 1, I2 is 1, we are getting 1 0, and I3 is 1, we are getting 1 1. And here in this case we have I3 equal to 1, I1 equal to 1, I0 equal to 1, and since this is a priority encoder, we are getting 1 1, which is I3's value. Okay, here also you can see I2 is equal to 1 and I0 equal to 1, and we are getting the value 1 0, which is corresponding value of I2. So this is how a priority encoder works and behaves. Let's write the constraint file. By this time you already know how to add the constraint file and how to add the switches and all. I'll add the switches quickly and I'll show it on the FPGA board. Okay, so I need 4 inputs. I'm gonna take the input from 4 switches over here and copy these 4 switches, paste it here and change the names. The output I'm gonna take it on LEDs. So we'll have 2 LEDs since we have 2 outputs. I'm gonna display it on LEDs, and here I'm going to select. Let's generate the bit stream now. Okay, so as you can see, the bitstream generation is completed, and I had made a mistake here. I had written I0 and I1. I noticed it later, so I changed it to I0 and Y1. So this is a basic change, and now I have connected my FPGA board. Now I'll upload the program over here. So go into hardware manager, go into open target and auto connect. And I'm going to program the device. Okay, so here is my FPGA board and it's now programmed, and current input here is 0 0. Since we have taken these 4 values as the input, current output is 0 0 and current input is all zeros. Okay, so all zeros doesn't matter. The first input, when I select the first input, it is going to show 0 0, representing that I have selected I1 as
I0 as the high. Okay, I can select the I1th as high, and it will show the first as the first LED as the output as 0 1, which is Y0 is equal to 1, Y1 is equal to 0. The third, if I turn the third one on, it is going to show 1 0, and if I turn the fourth one on, which is I3, it is going to show 1 1. Okay, so here, and now I'll show you the priority thing. So if I have, let's say, this one on, I2 as on, and even if I turn these guys on, nothing is going to happen, since the highest priority bit is this guy, and the corresponding output will be taken from this here. Okay, similarly, if I have this on, these all three will not affect anything, right? So this is the priority encoder implemented on the FPGA.
Okay, so just like that, we have completed the day 12 of the 100-day FPGA series. In this video, we covered priority encoder and implemented it on the FPGA. These small components and these small logics is going to help us in building larger things when we will be building complex designs. Okay, so this is the priority encoder. In day 13th, we are going to be doing the decoder, and in the same video itself, I will show you the encoder-decoder communication between the encoder decoder, okay, between two separate FPGAs. So in that will be covered in the same video itself, and stay tuned for that, and thanks for watching.